Yep. So I'm here to talk to you about using semantic packages for analytics. We were stuck on a really thorny analytics problem in our team, and we want to share the solution with you because we found it really exciting. So first off, a little bit about me. I'm Michael. I've been a product manager at Algolia for a little bit under a year. I am the product manager for a team called Optimization. We own analytics, A/B testing, and feature recommendations. So, a big ownership area, but yeah, lots of cool projects there. I'm going to do a brief agenda. First, I'm going to set up the problem that we're solving. Second, I'm going to introduce the semantic package and why we went with that as a solution. And third, I'm going to describe what happened when we implemented it and sort of the future vision for this product. So first off, we as optimization team own analytics across the product. So here's an example of how most people would interact with analytics. This is just the main analytics overview page. And you can see here, we're showing a bunch of different metrics about search. We're showing, total users, clicks, conversions, broken down in a bunch of different ways. So we're showing, top searches as well as these daily time series charts for each of these metrics. So for example, here's a zoom in now on a customer's specific top searches over a time period, but we're doing something similar for specific searches without clicks or searches with no results. All of these are designed to help you diagnose your search performance. And so the main customer problem we're trying to solve is to help customers understand and improve their search performance. But in addition to owning overall analytics, we also power each feature's analytics services. So that means that for each feature that Algolia makes, we are going to try to provide feature metrics for that for that experience as well. So here we're showing an example from the Visual Merchandising Studio. So another breakdown with its own set of aggregations and its own special cases. Here's another example around rules analytics, but Algolia is constantly shipping new features. So over time, we were experiencing a problem with scale. Like as Algolia was shipping more and more features, we needed to keep up with the pace of development. So we're managing all of these data products, and we start to hit a scaling problem. And then in addition, we have to manage calculations at many different levels of aggregation. So for example, we have searches without clicks. This is the top searches without clicks over a time period. So that's looking across the entire index. And on the right-hand side, we have a click-through rate and a no-click rate, which is done on a daily aggregation. Now, click-through rate and no-click rate sound really similar, and they use a lot of similar components. But as we'll see in a moment, we were doing them in a kind of inefficient way. So our previous way of calculating click-through rate and no-clicks rate was by sort of putting it on parallel tracks. Even though they reuse a lot of similar logics and a lot of and they kind of have a similar set of metrics underneath them, and even use some of the same numbers, we were doing them kind of one without touching the other. That kind of ensured accuracy and getting it right each time, but it's not very scalable and it wasn't very efficient and could lead to errors if there were errors in replicating those logics. So so that's one kind of summary of one set of dynamics with our analytics package. But in addition, our API design wasn't really well suited for the flexibility that a data product needs. So our initial API design was based off of coupling specific endpoints with specific metrics. And that makes sense for most APIs, but for us, that was starting to become incredibly rigid. And it meant that we had to add a new endpoint each time we wanted to add another metric. Also, because these names start to become quite similar, there are little situations where they start to appear quite similar, and it's unclear exactly what the API endpoint is calling. So that was another design flaw that we encountered. So putting it all together, there were three big flaws with our old analytics system. One, there was a profound lack of flexibility. Each time we had to add a new metric, it was painful. Second, for engineers, it was manual and repetitive work, so not a lot of fun. And third, and maybe most concerning, we were becoming a bottleneck for development. We were slowing Algolia down, and that wasn't very much fun. So then now I'm going to kind of start to outline what was the solution we came up with. So we wanted to create a much more flexible way for writing SQL queries and to use them more dynamically. So here, let me just walk you through this diagram a little bit. We have an events API. We have an events API that is how customers send us clicks and conversions. Then we combine that with sort of search engine logs, and together we call that the search data. And so we realized we had an opportunity to put the semantic package in front of that and to much more flexibly write queries and to sort of turn a query turn an endpoint into a series of parameters. But more on that later. So you can think of the analytics package as sitting in front of the search data, and is how our analytics API reads from that semantic package. So the next step in the solution was to break down queries into several components. So those components are familiar to anyone who's done SQL before. So some of these primitives include, sources. Here in this example, we have searches here. So sources, and then you select a series of columns. Then you can kind of do math transformations on top of them, any math function that you might imagine. And then there's also a layer of aggregations. In this example, we're going through click-through and conversion rate, which is two of the most common search health metrics that we show our customers. But it's very simple because each kind of level of aggregation is the same. So it's those two metrics map to each other quite easily. And then the next component was how important it was to recombine endpoints. So the fundamental advantage of the semantic package is it's a standard set of ways that allows you to retrieve metrics, filters, and groups. And as a result, you can sort of recombine little bits of logic. So here I'm bringing back the example from before of the click-through rate and the no-clicks rate. And we're able to reuse the logic of how we pulled clicks and click analytics from the search data, and also reusing tracked searches to make one metric calculation and to be much more efficient. So this ability to recombine and dynamically pull metrics was a key advantage of adopting the semantic package solution. So just kind of now the 10,000-foot view from above, we have this difference in what the world we had before and the world now. Prior, we had this very strict, calculating on parallel tracks set up. And in the world after, we had this ability to reuse, recombine different components of the query and to create a much more efficient way of calculating metrics. But we weren't done. We realized that now that we've sort of transformed endpoints into like a parameter that outputs a series of data points, we can combine that with UI components. So if you recall the analytics page, we had several different ways to display information to customers. And in these visualizations, there were they would be composed of many different metrics. So one example is a time series. So here it would be a daily time series. So the click-through rate on each day, and then also the overall click-through rate over the period. So we realized we could also turn the UI component into a kind of endpoint and generate all of the metrics needed for that. So that is a huge step up in efficiency of how we're able to serve analytics. So here's an example for time series. And then here's an example for a table. So a time series was sort of a daily aggregation, and then its table is looking at it, the top tables for the top results over a certain period. And then if you look at this, sample API response, we have endpoints for time series and table, and this allows us to power that analytics product much faster and much more swiftly. So overall, what this led to was an entirely new approach to analytics. We migrated our entire product to the semantic package, and next we made it available to feature teams. So this meant shifting our entire ownership of our entire model for how we would power analytics at Algolia. We were sort of the code owners, with allowing other feature teams to contribute it and to develop their own analytics on top of it. And so this shared ownership model really increased velocity and was a powerful lever for us. So if you think of just kind of the world we were before, the world we had after, before we had the problems of lack of flexibility, repetitive work, and it would take us up to 6 weeks to deliver a new set of metrics for a feature that was launching. A very painful process. And afterwards, we're talking about 1 or 2 PRs for each feature that needs to launch, and then maybe about 5 days of work for one engineer. So a huge acceleration in our development time for feature analytics. And then finally, I want to kind of paint a picture of what the future vision could look like. So one of the topics is possibly integrating semantic package with A/B testing. A/B testing is another area that we show a lot of metrics, and maybe the semantic package might lead to some advantages there. Another idea would be to allow Algolia customers to more flexibly create custom metrics and graphs. So allowing all of you to, ask to engage with the analytics feature, ask for very specific metrics, call those endpoints, and then pull a much wider variety of graphs. You can see some of our more experimental screenshots on the right-hand side there. And then finally, there's the possibility that we can combine this semantic layer with Algolia's MCP capabilities. So MCP is the model context protocol that allows LLMs to access APIs or to operate APIs. And we think there is a potential to kind of fuse these two things and to allow a semantic, flexible way of writing SQL queries to over time lead to advanced generative analytics. So I want to just outline a few of the key lessons we had from this project. So first off, when you're building data products and you're considering the API design, it's worth considering what is a parameter and what is a fixed endpoint. The traditional model of API design of one endpoint with one outcome might not be always the best. And secondly, platformization and shared ownership have huge potential for acceleration, and it allows you to serve many more use cases much more flexibly. But on reflection, I also believe we kind of engaged in that platformization at the right time. If we had done so too early, it probably wouldn't have led to as many benefits, and it might not have been as efficient. But eventually, once the previous model starts to hurt, you'll know that it's a good time to optimize. So lastly, get involved, and we are always looking for more feedback. So you explore the main analytics page of your Algolia dashboard. If you have any feedback on what metrics have been helpful to you, what metrics you would like to see, we're always listening to feedback from our community. Okay, and that's it for me.
Awesome. Thank you so much, Michael. Boy, you've really got my brain going on this one too, especially thinking about the future use cases. I'm imagining, I know we've got the Algolia Assistant now in the dashboard, and I'm imagining a world where I just describe the graphs and analytics that I want, and then suddenly there they are, right there, ready to deliver to my boss.
Absolutely.
Very cool. So my question to you is, well, I guess actually, first of all, I want to kind of open this up to the folks watching. Are these tools that you want? What are some of the gaps that you've seen in analytics that maybe, Michael could be thinking about? You can either tell us here now, or, as Michael said, jump on the Discord server and let us know over there. We would love to kind of hear the use cases that you would want. I love the idea of building out an MCP or integrating it into an MCP, because I'm starting to think in terms of maybe I've got another tool for some other data that I'm getting out of Google Tag Manager or some other thing, and to be able to aggregate data from there and from my search and be able to surface it all at once. That's cool. That would be incredibly powerful. Okay, let me check over on the Q&A section here. I don't really see any questions for you. I don't suppose you can share the models that you've been playing with, or is that kind of a secret sauce?
I think it's a little bit more of a secret sauce, but maybe we'll share more about that in the future.
Okay, that's fair. Don't mean to put you on the spot, but very much appreciate the presentation. I feel like analytics are kind of an under talked about section of the product. They're so incredibly important for improving relevance over time and sort of engaging, making it a search and communication, basically, right? Where it's a two-way sort of, you are delivering results, you're understanding how your users are engaging with those results, and you're constantly improving that relevance. So I think tooling like this is so amazing for being able to sort of improve that process and maybe, allow the system to sort of handle a little bit more of it on its own without having to, be as sort of human driven.
Yeah, absolutely. If you think about the kind of information that you would get that a customer or a search end user is telling you about themselves by telling you what they're looking for, it's really tremendous. The analytics information we have could tell you so much more about your own use case, your own product, or your own business.
Very cool. Well, thank you so much, Michael. Very much appreciate the presentation.